In this section, we're going to explore and introduce ionic compounds, compounds made of ions. And so we're going to start out by talking about ions themselves, which are distinguished into monatomic and polyatomic, meaning those containing a single atom versus a cluster of atoms. Then we'll talk about the formulas of ionic compounds, and then we'll talk about naming ionic compounds. And finally, we'll talk about how you know whether something is a covalent compound or whether it's an ionic compound just from looking at its formula. Okay, so the idea is that there are, in an atom, there are protons and neutrons in the nucleus, and those are surrounded by the electrons. And a large part of chemistry is that things gain and lose electrons. And when something loses electrons, they form positive ions, because electrons are negatively charged. And those ions, positive ions, are called cations. Cations are atoms that have lost electrons and now have positive charge. So magnesium atoms have 12 protons and 12 electrons. The 12 protons because it's atom number 12, element number 12. And so in a neutral atom, it has an equal number of electrons. But when it forms a cation, it loses 2 electrons. And when it loses those 2 electrons, what happens is it has 12 protons still. The nucleus remains intact. But now you're short 2 electrons. So now you have in the nucleus 12 positive charges. And in the electron cloud, you have 10 negative charges. So the positive charges outweigh the negative charges, so you have a total 2 plus charge. And so that ion has a 2 plus charge. And we write that as a superscript following the element symbol. Let's look at a little movie of this. That'll be fun. So you have 12 protons, 12 neutrons, 12 electrons. And when it forms an ion, 2 electrons leave. Those are them going. And the atom gets smaller when it turns into an ion because it now has fewer electrons. Let's watch that again. Get over there. Okay. So it's going. The 2 electrons here are the things they've lost. So lose those 2 electrons and it gets smaller. So this is now the ion. Those are the electrons. While we're here, let's look at what happens when an anion forms. An anion is a negative ion. A fluorine atom has 9 protons and 9 electrons. A negatively charged ion happens when something gains an electron. So an electron enters. That's our electron there. It's entering. The electron enters, and the thing gets bigger because it now has more electrons, and it has a negative charge. So anions are formed by gain of electrons. So a fluorine atom has 9 protons, 9 electrons. The fluoride ion has 9 protons and 10 electrons, so it has an overall -1 charge. And so that has a negative sign as a superscript in its formula. So cations are positive, anions are negative. Monatomic ions get the name, whatever the element is. Monatomic cations get the name of whatever the element is, just with the word ion on it. So Na plus is sodium ion. Magnesium 2 plus is magnesium ion. Notice that normally what happens is the name of the element doesn't tell you how many electrons have been lost, doesn't tell you what the charge is. The name of the ion doesn't tell you that. There's a special case for that we'll look at later on, but for the most part, you just say the name of the element and the word ion. For anions, that is negative ions, you change the name of the atom to an IDE ending. So oxygen 2 minus becomes oxide ion, which is similar to when you name an S2 minus as sulfide ion. It's similar to when you name covalent compounds that way. There are a significant number of monatomic ions that are always the same charge, that always have this, that never vary in what their charges are, and you need to remember these. So those in group 1A of the periodic table all have +1 charges. Those in group 2A all have +2 charges. Those in group 7 have -1 charges. Those in group 6 have -2 charges, or 2 minus charges. These ones up here, nitrogen and phosphorus, when they form ions, which is pretty rare, they make 3 minus charges. And the other one that's important is aluminum. It has a 3 plus charge. The transition metals, those in the middle, often have cases where they have more than 1 charge that's possible for the element. And so if we look at, for example, chromium, Chromium can either make 2 plus ions, or it can also make 3 plus ions. Same thing for iron and as well as cobalt. Same thing for copper, makes plus 1 and plus 2 ions. And so those you can't assume the ion charge from what the element is. Meaning that, for example, if you have calcium and you know it's making an ion, it's making a 2 plus ion. It always does. If you have iron, you don't know what ion it's making just from knowing that it's iron. To do that, to indicate which ion you do have, you use a Roman numeral following the ion. So let's say you have iron 2 plus. The way you would name that is iron, and then a Roman numeral 2 following it. And the way we call that, the way you say it, is iron 2 ion. And so chromium 3 plus is chromium 3 ion. Now let's talk about polyatomic ions. Polyatomic ions are, instead of being like atoms that have gained and lost electrons, polyatomic ions are molecules that have gained or lost electrons. So ammonium ion is formed by a nitrogen bonded to 4 hydrogens, where the overall structure has a positive charge. And so that's NH4 plus. That's called ammonium ion. Carbonate ion has a carbon bonded to 3 oxygens. One of those bonds is actually a double bond. You don't care about that yet. But it overall has a 2 minus charge, meaning it's like a CO3 molecule with 2 extra electrons. The ammonium is like an NH4 molecule that has lost an electron. And so those are called polyatomic ions. And there are a number of very common ones that you just need to memorize. And these are those. So you just need to memorize this list of polyatomic ions. You'll get used to them as you get along with them. Formulas from ionic compounds are based on the idea that the compound itself must not have any charge. So therefore, the total positive charge on the cations must equal the total negative charge on the anions. That is, the charges have to cancel each other, the positive and negative charges. So let's look at a little tool for looking at some examples of these. Okay, so what we're going to do here is we're going to take individual cations and pair them up with individual anions and look at what formula we get. So if we take, for example, lithium ion and fluoride ion, we get LiF, one of each. If we take sodium and fluoride, we get one of each, sodium and fluoride. Take sodium and chloride, NaCl, you know that already, that's one of each. Let's instead now take our chloride ion, which has a -1 charge, and look at calcium ion with it. That has a formula of CaCl2. That should be subscripted, by the way. And so what that means is that when a 2 plus ion is joined with -1 ions, you need 2 of the -1 ions to cancel the charge on the 2 plus ion. So we would expect barium ion and chloride ion to also have 2 chlorides. And so it does, BaCl2. If we look at iron 3 plus here with the chloride, that gives us FeCl3 because the iron 3 plus has a 3 plus charge and you need 3 chlorides to cancel those. If you have iron 3 plus and carbonate ion, let's see what we get then. We have 2 iron 3 pluses and 3 carbonate ions, because the carbonate ions are in parentheses there. So that means the ions add up to 6 plus, because they're 3 plus each, and the 3 carbonates add up to 6 minus, because they are 2 minus each. So the idea is you find a way that these two things can cancel each other. Okay, so let's look at some examples. What we would expect for magnesium 2 plus and Cl minus is we would expect for each magnesium that has a 2 plus charge, you're going to need 2 chlorides because they have a -1 charge each. So it's MgCl2. Mg2 plus and N3 minus, which is nitride ion. To get these to have the same charge, you need a common denominator of 6. So you're going to have 3 magnesiums, Mg3, N2, because the two nitride ions add up to -6, that's 6 minus. The 3 magnesiums will add up to 6 plus. Na plus and O2 minus, in this case you'll need 2 sodiums for each oxygen, because the sodiums are +1 each. Now, magnesium 2 plus and oxygen 2 minus, we have 2 options for this. We could say there's Mg2O2, because you have a 2 plus here and a 2 minus here, or it could just be MgO. And it turns out it's the bottom one. It's the simplest formula for that. Ionic compounds always use what is, in essence, an empirical formula. When you use polyatomic ions, when there are multiple ones of them, they're in parentheses. So if you have magnesium phosphate, that's 2 plus for these are 3 plus there. So to go together, you need 3 magnesiums, but you need 2 phosphates. So the phosphates go in parentheses. But you have to, of course, put the correct number, which in this case is 2, not 3. Because the phosphates are 3 minus, that adds up to 6 minus. The magnesiums are 2 plus, 3 of those add up to 6 plus. So you have to put that PO4 in parentheses to show that there are 2 of them. A common mistake is to use parentheses when there's only a single polyatomic ion, and you don't do that. So when you have magnesium phosphate, that's 2 plus, that's 2 minus. So your magnesium sulfate, it's that, MgSO4. It is not MgSO4 in parentheses. That's wrong. For ionic compound formulas, one of the things that's important to realize is that these have no molecular formulas because you don't have individual molecules. You have this big extended thing. So here's the structure of sodium chloride. It goes out millions and millions of atoms in each direction. It's a giant, on the molecular scale, a giant molecule containing millions and billions of ions. And so it doesn't have any molecular formula like H2O does because it isn't made of individual things. So the formula tells you the relative number of each of those ions, but it doesn't tell you how many exact ions are in a particular crystal of that ionic compound. Ionic compounds, by the way, are also called, in general, salts. Salts is another word in general that are used. So NaCl you know as table salt, but salt is also a general term used in chemistry for meaning ionic compounds. When you name ionic compounds, you essentially just take the two names, the anion and the cation, and put them together. The thing that's different from covalent compounds is you don't use the prefixes like di and tri and stuff like that. So NaCl is sodium chloride because the sodium ion is the cation, the anion is chloride ion, so you just call it sodium chloride. MgCl2 has magnesium ions and chloride ions, and so it's magnesium chloride. It is not magnesium dichloride. It isn't that. And how do you know that? If somebody just told you I have magnesium chloride, how do you know that there are two chlorides from just that simple name? You know it because earlier on we learned that magnesium always makes 2 plus ions. Chlorine always makes -1 ions. Those have to go together so that the charges cancel. So you have magnesium Cl2, MgCl2, because you know that the charges are defined by where they are on the periodic table, and they have to go together to make them neutral, so you have to have 2 chlorides for each magnesium. Okay. This will be sodium sulfate. And this final one here, sorry it's a little hard to read, is ammonium phosphate. Notice that you don't call, there's nothing in the name that tells you how many ammoniums or how many phosphates. You know ammonium has a +1 charge. You know phosphate has a 3- charge. Therefore, there must be 3 ammoniums for each phosphate. The only place this happens is when you have, that differs with that, is when you have transition metals. So if you have CrCl2, you know from the 2 Cls that those must have a total 2- charge. Therefore, the chromium must be +2. Therefore, this is chromium 2 chloride. So you take what you know and you work back from there. So in this case, you know that phosphates have a 3- charge from your table of polyatomic ions. Because this has to be neutral, the cobalt must be 3+. So that's cobalt 3 phosphate. Finally, how do you know when you just get a formula? How do you know whether it's an ionic compound or a covalent compound? How can you tell the difference? The rules are that ionic compounds are made between metals and nonmetals, or between metals and polyatomic ions, or between two polyatomic ions. Covalent compounds are always made between two nonmetals, but they can't have polyatomic ions. So what you do is you look on your periodic table, and if you have an example of, let's say you had N2 Cl4. How do you know whether that's an ionic compound or a covalent compound? You look on your periodic table and you see that nitrogen is a nonmetal, chlorine's a nonmetal, so it's just made between two nonmetals. They're not using any common ionic polyatomic ions, so that would be a covalent compound. If you had, for example, calcium and Br2. Calcium's a metal, bromine's a nonmetal, therefore it's an ionic compound. If you had something that contains, anytime you have contains something that contains polyatomic ions, you know it's an ion. So if you have something that starts with, say, NH4 and goes on from there, it doesn't even matter what goes on from there. That's going to be an ionic compound because that's an ion, and you know that's an ion.